This is GAVIGO IRE, the Instant Reality Exchange. The dashboard is divided into three main panels. On top, the activation monitor tracks real-time engagement and container warming. In the middle, the proof signal log shows every container's journey through the activation pipeline. At the bottom, the resource allocation chart displays system-wide resource distribution over time. Let's start with the activation monitor. The green pulsing dot indicates that users are actively using the mobile app right now. The content selector lets you jump to any game's telemetry. The feed context header shows the active content title, a live focus timer counting how long the user has been viewing, the engagement score, and the scroll position in the feed. The look-ahead preview shows which upcoming items are already being pre-warmed. Below that is the warming progress section. The animated progress bar shows the combined engagement score, ranging from 0 to 1. When the score crosses the 0.6 threshold, container warming is triggered. The score is a weighted combination of three inputs. The personal score, which increases by 0.1 per second of viewing. The global score, which reflects aggregate engagement across all users. And the combined score, calculated as 40% personal, 40% global, and 20% trend. When a container activates, the lifecycle section appears. It shows the activation path, blue for cold path, meaning it started from scratch, yellow for pre-warm path, meaning AI predicted the user's intent and preloaded the container, or cyan for restore path, meaning it was restored from a snapshot cache. You'll also see the cache hit indicator, the trigger type badge showing which AI rule fired, such as proactive warm, look-ahead warm, or cross-domain, the AI's reasoning in plain text, and detailed latency metrics, decision time, pre-warm duration, activation latency, and total intent-to-ready time. The proof signal log provides a visual timeline of each container's lifecycle. The current game is pinned at the top with a Now badge. Its pipeline visualization shows exactly which stages have been reached. Interest detected, AI preparing, loading, standby, activated, running, and ready to play. Each stage is represented by a distinct icon and connected by animated lines. If the container was restored from cache, it shows a special restore path instead. Below the current game, all other containers are listed and sorted by temperature. Hot containers at the top, then warm, then cold. Each card displays the game title, container status badge with a colored glow, the pipeline stages it has completed, the path type label, the AI trigger reason, a timestamp, and its position in the feed relative to the current content. The resource allocation chart is a time series line graph showing the last 30 data points. Three color-coded lines represent hot containers in red, fully active and serving users, warm containers in amber, on standby with minimal resources, ready for instant activation, and cold containers in blue, scaled to 0 with no resources allocated. Below the chart, three cards show the current percentage for each state. The dashboard works alongside the mobile app in a split-screen view. On the left, users scroll through a TikTok-style content feed. On the right, the dashboard updates in real time via WebSocket, showing exactly how the AI orchestration responds to each user interaction. This split view makes the entire decision process transparent. Here's how it all connects. When a user scrolls to new content in the mobile app, engagement signals start flowing. The personal score rises as viewing time increases. Once the combined score crosses the 0.6 threshold, the AI decides whether to warm the container proactively, restore it from cache, or cold start it. The activation monitor displays this decision in real time. The orchestration log records the pipeline stages, and the resource chart shifts its hot, warm, and cold allocation percentages accordingly. Under the hood, the front-end dashboard is built with React and TypeScript. The orchestrator runs on Go. Real-time communication uses WebSocket and Redis, and everything is deployed on Google Kubernetes Engine. GAVIGO IRE, Instant Reality Exchange.